In previous lesson, we learned about weight. There is a downward force experienced by all objects on Earth because of the Earth's gravity. In this lesson, we are going to look at another force that exists in all situations when two objects touch each other. For example, when you are standing on the floor, your feet is touching the floor. So your feet push downwards on the floor because of your weight. And even though you do not feel it, the floor is actually pushing back upwards at your feet. These two forces are called contact forces, and they are a pair of action and reaction pair of forces that is described in Newton's third law of motion. These two contact forces exist in pairs, and they are equal in magnitude but opposite in direction, and they act on mutually opposite bodies. But where does the contact force comes from? If you're standing barefooted, you might not see anything. However, if you're wearing high heels on wooden floor, you might see marks left on the wooden floor. So what this tells us is that when you stand on the floor becomes slightly compressed. Its atoms are pushed slightly closer together. And the interatomic forces will therefore tend to push back against the compressing force. Contact force exists when two objects touch each other. Contact force is sometimes called the normal reaction of a force. Normal here means perpendicular. Contact force always acts at right angle to the surface which produces it. In this slide, the ladder is supported by the floor and leaning against the wall. Hence, there are contact forces at the wall as well as on the floor. If you are asked how many contact forces are acting on this ladder, the answer is there are two contact forces acting on the ladder. One is at right angle to the wall and another is in right angle to the floor. We know that all objects will fall to the ground because of the pull of gravity, which is the object's weight. So when we stretch out a hand to support it, the contact force has to be equal to the weight of the object. If we were to draw a free body diagram for this book, you will have a downward weight and an upward contact force acting on the book by your hand. Take note that as explained in Module 1, when we learn about Newton's third law of motion, the weight and the contact force are two forces acting on the book, but they are not a pair of Newton's third law action-reaction forces, although they are equal in magnitude and opposite in direction. Because these two forces are acting on the same body, that is the book, and they are not of the same type of forces. One is a contact force, and the weight is a gravitational force exerted by the Earth. In reality, the contact forces are a pair, one exerted by your hand on the book and one exerted by the book on your hand. And the weight, which is a gravitational force, also exists in a pair, one exerted by the Earth on the book and the other exerted by the book on the Earth. But when you work on solving dynamics question, you do not draw every forces. For example, if you are given a book resting on the table, and if you were to have all the forces drawn, it will be so confusing. If you are asked to identify the forces and the effect of the forces acting on the book, then the book shall be your focus. You only draw the weight acted by the Earth on the book, and ignore what the book acts on the Earth. And you draw the contact force that the table acts to support the book, and ignore the contact force that the book acts on the table. In this way, you can easily see that there are two forces acting on the book that is equal in magnitude but opposite in direction. That means the forces are balanced, and the effect is that this book is in equilibrium, and that explains why the book is at rest. From this example, you shall notice that when you draw the free body diagram, it is important that the length of the arrow representing a given force is proportional to the magnitude of the force. In this way, you can see the effect of the forces very clearly. In summary, when two objects touch each other, each exerts a force on the other. Contact forces is in accordance to Newton's third law of motion, and contact force always acts at right angles to the surface which produces it. It is also called the normal perpendicular reaction.